On question number 6, we're told to sketch a slope field. And we can start by doing a phase portrait because we have an autonomous ODE. To sketch the slope field, I think that the easiest way to start is to find the critical points. Where is the derivative equal to 0? Or where is y to the third minus y squared equal to 0? With y to the third minus y squared, you can factor out the y squared so that you have a y minus 1 factor. And setting my factors equal to 0, I'm going to end up with y is equal to 0 from this first factor. And from y minus 1 equals 0, I'm going to end up with y equals 1. Those are my critical values. So my phase portrait, that's a vertical line. Y equals 0 and then y equals 1. For my phase portrait, I want to find out where my slope is positive and where it's negative, and then identify my attractors and my repellers. Where's the graph stable and where is it unstable? So I'm going to choose a test point. Let me just change my ink for the test points. I'm going to choose value of 2 above 1, and when I check y equals 2, I'm going to check it in my derivative. So I get dy dx equals, let me just plug it in to my derivative here. I'm going to get 2 to the third minus 2 squared. And really all I need is this positive or is this negative? And I end up with a positive 4. And because it's positive, I know that my function is increasing when y is greater than 1. So let me change my ink color. Choose blue. I'm going to choose a test value in between 0 and 1. Let me choose 1/2. When I choose 1/2 and check the result in the derivative, I get dy dx is equal to 1/2 to the third power minus, that's a 1/2, minus 1/2 to the second power. If you want, you can use a calculator to do this. One-eighth. I know that 1/4 is greater than 1/8, so when I subtract, my answer is going to be a negative. And in fact, 1/4 is the same as 2/8. Multiply this second fraction by 2 over 2. You get 1 minus 2 gives you negative 1 over 8. Negative 1/8. The point is that it's negative in between 0 and 1. And then less than 0, you might choose something like negative 1. And if you test negative 1 in the derivative, you get negative 1 to the third minus negative 1 squared. That's going to give us negative 1 minus 1, or negative 2. The graph is negative below 0. Okay, now let's label our points. At 1, the graph above 1, y equals 1, is increasing, and below it's decreasing. So from both directions, the graph is flowing away from it. So y equals 1 is a repeller, and that means it's unstable. Here at 0, above 0, my graph is coming closer to that critical value. Below 0, my graph is moving away. So 0 is not a repeller, and 0's, well, actually 0's a repeller from beneath it, and it's an attractor from above it. and so it's really considered neither to be an attractor nor a repeller. Here at 0, this is called semi-stable. And it's neither an attractor nor a repeller. It's semi-stable because from above the line is going to come and come down to the line y equals 0, and then from below the graph is going to go away from it. Okay, so let's draw our picture. I think we have enough information to draw the picture. So I'll draw my rectangle. I apologize, my rectangles are never square. There's my axes. Let me change the color. Do it light green. And my critical values are at y equals 1 and y equals 0. Y equals 0 is the x-axis. And I'll label this y equals 0. And y equals 1, put it anywhere above. Y equals 1. I know that at y equals 2, my slope is 4. A slope of 4 means 4 up, 1 to the right. So my slope lines should look something like that at y equals 2. Y equals 2 would be right about here. So I'll try and get those. Those should all be the same slopes. The important part is that it's positive, and it's leveling out at y equals 1. So it's going to be relatively level and then go up. Relatively level, go up. In between 0 and 1, my slope is going to be negative. It's going down. And at 1/2, I have negative 1/8. That means down 1 to the right 8. It's going to be relatively level right at 1/2. Okay. And above, this is starting to level out even more. And below, this is leveling out this way. Lost my mouse. Okay. Below y equals 0, our graph is also negative slope. And at negative 1, we have a slope of negative 2, down 2, 1 to the right. So at negative 1, that'd be about here. I've got a slope something like this. And I know that that levels out at y equals 0. So it's a little bit more level up here. And it's going more negative slope down here. Okay, and there's our slope field. Now what I'll look for, if I give you one like this on a test, is I'll look to see that you've got these labeled, the critical values are labeled, and you have those horizontal line segments there. I'll look to see above, is that a positive slope? Does it come even? Does it level out as it gets close to the critical value? Level, show the slope, level, and then level close to y equals 0, and negative slope in here.